Hey guys, Mr. McKinney here, just going through our Unit 4 review session. Unit 4 basically had two main topics. We talked about implicit differentiation and we talked about related rates, which were basically just word problems. Implicit differentiation just meant you were taking the derivative without solving for y first. And we also talked about taking the derivative with respect to a variable that was not in the original equation, which is what we do on a lot of these word problems. We take the derivative with respect to t, even though t is not in those problems. Implicit basically just is talking about you don't have to solve for y. So if we look at this equation over here, you don't have to solve this for y first. You can just take the derivative as it is. And the reason you would need to do that is because you can't solve for just y on this equation, because it's not a function. There's three different functions that are happening here, this pink one, this blue one, and this black one. So you can't really solve for y, or you'd have to solve for three different functions. But you don't need to. You can just take the derivative from that original form. And that's what implicit differentiation is. So if I want to find dy dx, if 3y squared plus 2x equals 5y, I use all the same rules as before, I just don't worry about solving for y first. So dy dx means we're taking the derivative with respect to x of y. That's what this means. So the d dx is the derivative with respect to y. Sorry, to x. So we're taking the derivative with respect to x of y. It's really important to look at whatever is on the bottom. So in this case, we're taking the derivative with respect to x. On a lot of the word problems, you're going to look at the units and see seconds or minutes or hours on the bottom. And that's how you're going to know you're going to take the derivative with respect to time. Okay, so here we go. Derivative of 3y squared. We're going to use the power rule, so 6y. And then we're going to use the chain rule, so the derivative of y with respect to x. And then 2x. We're going to take the derivative. The derivative of a linear function is a constant, so the derivative of 2x is 2 times the derivative of x with respect to x. But the rate of change of x with respect to x is always going to be 1. So we don't really need to write that because it's 2 times 1. And then the derivative of 5y would be 5, and then times chain rule, so the derivative of y with respect to x. So we were taking the derivative with respect to x. When I took the derivative of y, I needed to write it. When I took the derivative of x with respect to x, you don't need to write it. So that's just 1. You don't have to write this step. All right, so now we want to get dy dx on the same side, factor it out, and solve for it. So I'm going to subtract this term over to the left side and subtract the 2 over to the right side. So equals -2. Over here, I'd have 6y dy dx minus 5 dy dx. Pull out the dy dx times 6y minus 5. And then divide both sides by the 6y minus 5. So dy dx on this problem would be -2 divided by 6y minus 5. Notice that our slope equation on this problem is defined in terms of y. So sometimes you're going to end up with dy dx in terms of x. Sometimes you're going to end up with dy dx in terms of y. Sometimes you're going to end up with dy dx in terms of x and y. So just be careful and make sure you're following the rules, and it'll take care of itself. All right. So here's the steps. Basically just do the derivative like you have been. Make sure you do the chain rule. Get all the dy dx terms on one side, factor it out, and then divide. This is probably the most important step. Make sure you get all the dy dx terms on one side and everything else on the other side. All right, so I want to find dq dp if the fifth root of q squared is equal to 4p squared. Now, we're just switching up the variables. Nothing's really different, but we need to practice getting used to working with different variables. So look on the bottom. That's going to tell you what you're taking the derivative with respect to. So in this case, we're taking the derivative with respect to p. Now, it's easier to take the derivative if we rewrite this as an exponent. So q, this is the power and the root. So q to the 2/5, and then equals 4p cubed. So we're going to be taking the derivative with respect to p. So when I take the derivative of q with respect to p, that's where my dq dp term is going to come in. When I take the derivative of p with respect to p, dp dp is going to go away. But I'm just going to use the power rule on both sides and then use the chain rule with respect to p. So on this side, I would get 2/5 q to the negative 3/5 because I take away 1. And then the chain rule, so the derivative of q with respect to p. And then over here, I would get 12p squared. And then the derivative of p with respect to p, I don't need to write. That's just 1. So when you're taking the derivative with respect to that variable, you don't need to write the dp dp or dx dx. If you want to and then cancel it out, you can, but you do not need to show that on the AP exam. All right, so we want to define dq dp. This is what we want to find. So I just need to isolate it. I need to get this stuff over to the other side. So I can divide both sides by 2/5 q to the negative 3/5. So divide by 2/5 q to the negative 3/5. Now technically, I can just leave my answer like this if I'm on the free response portion of the AP exam. But they would probably simplify it, and this would probably be on the multiple choice portion, so let's practice that. 12 divided by 2/5 is the same as 12 times 5/2. Cancel these out, so that would be 30. So 12 divided by 2/5 is really 30. P squared and q to the negative 3/5 aren't really going to be able to cancel out at all because they're different variables. But the negative exponent here can move up to the top. So I'm going to have 30p squared and then q to the 3/5. This is equivalent to this, but this is the answer you would probably see on the multiple choice exam. Okay, the last thing I want to talk about before we start switching up the variables a little bit more is how to do the product rule with an implicit differentiation. So find dy dx. The thing on the bottom is telling us what the derivative is with respect to. So that's a really important step on these problems, is figure out what are we even taking the derivative with respect to. Now I'm just going to use my derivative rules on all the pieces, but on this part right here, I'm going to need to make sure I use the product rule. So derivative with respect to x, and for this part, I'm going to think about it as 9x times y. Those are two functions multiplied, so I have to use the product rule. So the derivative of x cubed with respect to x would be 3x squared dx dx. I'm not going to write it. The derivative of y cubed would be 3y squared, and then it's the derivative of y with respect to x. So I do need to write this part, dy dx, minus, I'm going to put a big bracket because I'm going to have two pieces here from the product rule, and I need to make sure that this negative gets distributed to both of them. So first I'm going to do 9x times the derivative of y. The derivative of y with respect to x would be dy dx. And then I'm going to do y times the derivative of 9x. The derivative of 9x would just be 9. Derivative of a constant, whether it's 0 or not, is 0. Okay, so now I need to get my dy dx terms on one side and get everything else on the other side. Now I'm going to distribute this negative before I start moving things around. So 3x squared plus 3y squared dy dx minus 9x dy dx minus 9y equals 0. All right, this is the terms that I need to keep on the left side. So these other two are going to move over to the right side. So 3y squared dy dx minus 9x dy dx equals, and then this 9y is going to become positive. The 3x squared is going to become negative. Pull out the dy dx. It'll give us 3y squared minus 9x. And then we're going to divide both sides by the 3y squared minus 9x. Now, you can leave it like this if it's free response. They would have they would have divided everything by 3 if it was a multiple choice. So you'd have 3y minus x squared over y squared minus x. Now, if all of your negatives are switched, that's fine also. So if you have like negative 3y plus x squared and negative y squared plus x, that's fine. That would have just been like multiplying the entire top and bottom by a negative. Now I did lose a factor of 3 here. This should have been minus 3x. So 3y minus x squared over y squared minus 3x. Main thing is you have to use the product rule here. Keep in mind that when you take the derivative of y, you need that term. When you take the derivative of x with respect to x, it goes away. Now a common question is, can we use y prime instead of dy dx on this problem? And the answer is yes, that's fine. You can use y prime here. And for some of you guys, it'll make it easier to keep track of things. I wrote dy dx to emphasize what's going on these problems. Okay, now let's see what happens if we find the second derivative when we're doing implicit differentiation. So we start by taking, and again, what's on the bottom is telling us what we're taking the derivative with respect to. So this is asking for the second derivative with respect to x. So let's take the first derivative with respect to x and then the second derivative with respect to x. So we're taking the derivative with respect to x twice of y. And that's why we have this notation, d squared y dx squared. Okay, so I'm going to rewrite it over here. X squared minus 2y squared equals 49. We're going to take the derivative with respect to x. So the derivative of x squared would be 2x, dx dx, I don't have to write. Derivative of 2y squared would be 4y. Since we're taking the derivative with respect to x, I do need this dy dx. Derivative of a constant is 0. So now I just need to solve for my dy dx. So I'll subtract that 2x over and then divide by negative 4y. So I'm going to get negatives cancel out a factor of 2. So I would get x over 2y. So that's the first derivative. So if I want to get the second derivative, I need to take the derivative of this equation. So I need to take the derivative with respect to x. And I'm going to rewrite it over here and switch colors for the second derivative. So dy dx equals x over 2y. And now to get to the second derivative, I'm going to take the derivative with respect to x again. So the derivative of dy dx is the second derivative of y with respect to x. Now on the right side over here, I would have to use the quotient rule. So on the bottom, I'm going to have 2y squared, and I'm going to start with that 2y on top. The derivative of x with respect to x is just 1. And then I'm going to have the top times the derivative of the bottom. The derivative of 2y with respect to x is 2 dy dx. Now I can't stop here. I need to plug in my equation for dy dx. So I'd have 2y minus x times 2, and then dy dx is x over 2y. Over, I'm going to go ahead and multiply that out and make it 4y squared. Now this is fine. I'm going to show you guys a couple of the other ways that it would probably be simplified if this was the multiple choice. So we'd multiply this out. These 2's could cancel, so we'd have x squared over y over 4y squared. And then a common thing you would see is to get rid of the fraction on top. So we can multiply the top and the bottom by y, because we're really just multiplying by 1, and you're allowed to multiply by 1 whenever you want. So another answer choice you might see would be 2y squared minus x squared over 4y cubed. Now really, any of these are fine. So this one would be fine, this one would be fine, this one would be fine. But you can't stop here. You need to make sure you plug the original derivative back in for the second derivative. All right, so that's going to wrap up our first half of the Unit 4 review videos, and then we'll pick up starting with this slide on the next one.